Hello, my name is Hunter Cockrell, and I'm going to be doing my project over IPv6 readiness evaluation of IoT devices. Um, I'm going to start with the basics. Uh, Internet Protocol, or IP, is the communications protocol that routes traffic across the internet. Right now, the Internet Protocol version 4, or IPv4, carries most of the internet's traffic. As you can see in the map in this diagram, it shows that it shows the IP addresses that are used worldwide. As you can see, in the United States and in Europe, it's widely used compared to most of the world. This creates a huge shortage of IP addresses, which leads to the reason being why we need IPv6 addresses. Um, However, that's going to change due to a shortage of IPv4 addresses. The shortage exists because IPv4 allows approximately 4 billion addresses, and that sounds like a lot, but with everything that we have, every smartphone, laptop, tablet, everything that's connected out there, we're else these days we're needing IP addresses, and they're almost all gone. IPv4 addresses are already reaching depletion in Asia and the Pacific, where the first hit of depletion in April of 2011, and since then everywhere else but Africa has also become depleted. The good news is that we do have IPv6. IPv6 has been around for a while. It's nothing completely new, but it does give us something as a, not necessarily a backup, but a change. And the thing is that whenever we implement this, most people won't notice the change, but there are certain things that will notice the change, like we'll learn in IoT devices later on. Internet Protocol version 6, or IPv6 addresses this problem. The limit to the number of IP addresses is exponentially higher than the IPv4 limit. Approximately 42 undecillion unique addresses. That's the number 42 followed by 36 zeros. So what's the difference between IPv4 and IPv6? IPv4 addresses consist of 4 parts of 8 bits each for a total of 32 bits, and they use dotted decimal notation. Really, they're not that much different than your typical phone number, I guess is the way you could look at it. IPv6 addresses are quite a bit more complex. They consist of 8 parts of 16 bits for a total of 128 bits, and can include hexadecimal digits and use string notation. Instead of just numbers, you'll see a combination of numbers A through F. So what are the benefits of IPv6? Well, you obviously get, better security. IPv4 is limited in that, being that it's been around so long that we are starting to run into issues with that. Faster forwarding rates, stateless or stateful address configuration, and extendable headers as well. Now we'll get into IoT devices. What exactly is an IoT device? The Internet of Things is the concept of everyday objects, from industrial wearable machines to wearable devices, using built-in sensors to gather data and take action on data across a network. So it's a building, so it can be a building that uses sensors to automatically adjust heating and lighting, or production equipment alerting maintenance personnel to for an impending failure. Simply put, the Internet of Things is the future of technology and can make our lives more efficient. You have Internet of Things all around you in reality. Basically, it can be anything from an Amazon Alexa, which I have frequent in my house, your wearable devices like your Apple Watch or Samsung Gears, or it can even be your refrigerator. Your refrigerator now can be an Internet of Things, and it can do many things, like you can have cameras and it can tell you different stats that are running on the thing. I'm actually going to have a video real quick that's going to demonstrate exactly what the Internet of Things is, and we will get that started.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom-built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
So why is IPv6 important in IoT? Well, security, scalability, and connectability. With billions of new smart products being created every day, security is an important thought in the backbone of all IoT engineers' minds. Organizations and individuals have learned of the real and intimate threat that hackers pose in the past, but the IoT brings up a whole new line of security intrusions. Hacking a secure network and harvesting millions of credit card numbers is terrible, but if someone with ill intentions was to hack a small city or a neighborhood of smart houses, the outcome could be far more catastrophic. You can tell why IoT is very important, and the good news is that IPv6 offers better security solutions than the predecessor, largely due to IP6. According to a report by Gartner, 25 billion things, IoT devices, will be connected to the internet by the year 2020. That's an incredible estimation, considering that the same report notes that 4.9 billion devices will be connected by 2015. That's proposed 400% increase in the growth in the next 5 years, which sheds some light on how exponential the growth will be in the next 10, 20, or even 50 years. With billions of new IoT devices entering the market each year, connectability, allowing the network connect devices to speak to each other, is vital. With IPv4, there were quite a few issues with allowing IoT products to speak with one another. Network address translation, otherwise known as NAT, posed one of these major issues. NAT was created as a workaround for organizations who needed multiple people and devices to be able to work off of the same IP address. Not only does this pose a security issue, but it also poses difficult for IoT products. IPv6 IoT products will be uniquely addressable without having to work around all the traditional NAT and firewall issues. Larger and more advanced host devices have all sorts of tools to make working with firewalls and NAT routers easier, but with small IoT endpoints devices, they do not. By using IPv6, many of these issues become easier for TCP/IP enabled IoT devices to handle. So, are we ready for IPv6 and IoT? In my mind, I say yes and no. With new IoT devices coming out what seems every week, you would think they would be coming out more future-proof using IPv6. However, that's not always the case. Like, for instance, some of my IoT devices that I have, like some of my headphones, some of my Amazon Alexa, different things like that. Some of them do implement IPv6, but a decent amount of them still do not. The standard seems to be in most of my IoT devices that they're still using IPv4, still skipping out on the new IPv6. That could be also because some of my devices are getting to their end of life, but I would say for right now, also in the current standards, most devices are using IPv4 still. And with all these new devices being developed through, it's no wonder we have a shortage of IPv4 devices. Companies, though, are working to implement IPv6. It's just taking time, and I put that in quotations because it's been around since 2012. And with that being said, it's kind of like, the tech world. It moves every year, moves 10 years in advance, and that's the way I look at it. And so, with that being said, I feel like it's not moving as fast as it could, or we're taking our time doing it. So, I say yes and no. I'm leaning more towards yes, we are, but no, we're just taking our time doing it. So, that's all I have, and thank you.